19th century mathematics is the era in which engineering and applied mathematics arose, and is often called the Age of Revolution. Most of the famous contributors in this period are from Germany and France. Carl Friedrich Gauss, a German mathematician, also called the Prince of Mathematicians. By the age of 7, he shocked his teacher by instantly calculating the sum of integers from 1 to 100, just by recognizing a pattern of pairs that always added up to 101. Moreover, at the age of 22, he presented proofs for fundamental theorem of algebra, doing so in his 1799 doctoral dissertation, which states that every non-constant single variable polynomial with complex coefficients has at least one complex root. For example, x squared plus 1 equals 0, x squared equals -1, square root of x squared equals square root of -1. But there are no real numbers. Multiplied by itself results in a negative. So there is no solution? No. That is square root of -1. And that is an example of an imaginary number, which is also an example of a complex root. Évariste Galois, born on October 25, 1811, in France, in the town of Bourg-la-Reine. For the first 12 years of his life, he was homeschooled by his educated mother, and then entered in one of the most prestigious secondary schools in Paris, the Lycée Louis-le-Grand. But the headmaster held him back from advancing to a higher level. Due to that, he was too young, leading to demoralized him. However, one of the teachers recognized his brilliance, Louis Paul-Émile Richard, whom encourages him to pursue his mathematical ideas. He solved one of the great mysteries in math, the quintic equation, where x is raised to the power of 5. For centuries, mathematicians could not find general formula to solve quintic equations using general operation, but Galois went further. He rearranged a polynomial's roots in different ways without changing the equation. Those arrangements form a group, a set of operations that follow clear rules. He realized that the roots of a polynomial equation can be swapped in similar way, forming a group called a Galois group. By studying the structure of that group, he can determine whether an equation is solvable using just arithmetic and roots. He submitted his papers to some famous mathematicians, including Cauchy, Gauss, and Poisson. Yet he received constant rejection. Then he died at the age of 20 due to a duel, a tragic and terrible ending of his life. Arthur Cayley, born on August 16, 1821, in Richmond-sur-Ury, England. He was the man who helped build the foundation of modern mathematics. However, almost no one remembers his name. He developed the matrix algebra and worked on non-Euclidean geometry. Also, a pioneer of group theory. But one of his famous an influential theorem in mathematics, is the Cayley's theorem, particularly the abstract algebra, which states that every group is isomorphic to a permutation group. In other words, permutation group is a group of permutation on a set, and a permutation on a set is just a bijection from that set to itself.
Bernhard Riemann, born on September 17, 1826 in Germany. He originally entered the University of Göttingen to study theology to please his father, but after hearing lectures by Carl Friedrich Gauss, he switched mathematics. Then he moved to Berlin to study together with Dirichlet and Jacobi. He proposed that space could be curved and that its property could change from point to point, which is called the Riemannian geometry. Moreover, in 1859, he introduced the Riemann zeta function. He proposed a hypothesis about the zeros of this function, suggesting they all lie on a specific critical line, what known today as the Riemann hypothesis, one of the Millennium Prize problems. Sofia Kowalewskaya. Born in Moscow, she was the first woman in Northern Europe to hold a full professorship, a brilliant analyst, gifted writer, and a defiant advocate for women's right to higher education. As a child, she stared for hours at the wallpaper in her room, made from her father's mathematics lecture note. At her time, Russian women were not allowed to attend university or travel abroad with husband's or father's permission. That's why she entered into fictitious marriage. She studied with Weierstrass in Berlin. However, she encountered problems there since she was bored from attending university lectures because she is a woman. Nevertheless, Weierstrass agreed to tutor her privately for 4 years. Her famous work is the Cauchy-Kowalewskaya theorem, contributing to the field of partial differential equation. It provides the condition under which a unique solution exists for a wide class of partial differential equations. It guarantees that the partial differential equation problem has one single analytic solution in a small region around the initial data.
Modern science and technology are built upon a mathematical foundation laid by these visionaries, whose theories provide the structural DNA for our understanding of the physical world. By utilizing Gauss' control theory to stabilize aerospace and robotic systems, and Riemann's non-Euclidean geometry to map the very curvature of space-time in general relativity, we are able to navigate both our planet and the cosmos with precision. This physical framework is further refined by Kowalewskaya's foundational work in partial differential equations, which allows us to model complex phenomena like heat flow and fluid dynamics, while Cayley's group theory enables the precise calculation of 3D rotations for robotics and drones. Ultimately, these tools coalesce through Galois' insights into abstract symmetry, providing the essential language for physicists to uncover the hidden structures of the universe, from the microscopic behavior of subatomic particles to the macroscopic organization of crystals.
Aren't mathematicians amazing?